This next problem is for you folks to try. It's taken from the assigned homework, number 79. Tangent of 2 arcsine of -1/3. So you're using the double angle formula for tangent, and I'll just remind you, this is actually very similar to the last problem, because when I'm saying that this thing, I'm just going to call it theta, is arcsine of -1/3, that's giving you some information about what sine of theta is and about what quadrant it's in. It's just expecting you to remember the definition of arcsine to be able to figure that out. So pause the video, try to work this out, and then we'll take a look at it together. So I've written out the double angle formula for tangent here, and of course theta is just arcsine of -1/3. So this is tangent of 2 theta, where theta is arcsine of -1/3. So if theta is arcsine of -1/3, that tells me two things. Sine of theta is -1/3, and theta is in the interval from -π/2 to +π/2. And of course that interval corresponds to quadrants 1 and 4. Since that's a negative number and sine is negative in quadrant 4, I know that theta is in quadrant 4. Okay. So I want to try to figure out what is tangent of theta. And my picture is like this, that theta is just a negative acute angle. Alpha would be the opposite of that, the same amount of rotation, but just counted as a positive measure. Okay. Since we're in quadrant 4, I know that tangent will be negative. If I look at the reference angle, I know that sine of alpha is the absolute value of -1/3, which is 1/3. Okay. That's actually the number we had last time. I wasn't really thinking when I chose this problem. All right, so I'm going to label the opposite side 1, the hypotenuse 3, and as we just saw in the last problem, that's going to make the adjacent side 2√2. Okay, and so tangent would be opposite over adjacent. So 1/2√2 is the absolute value. That's tangent of my reference angle. We attach that to the negative sign, and that gives me tangent of theta. Of course, we're going to want to rationalize that, although I think what I'm going to do, do I want to rationalize it? Let's rationalize it first. Okay, so to rationalize it, I'm going to multiply by 1 in the form of √2/√2. I was thinking we might just plug in here as is, because here we will be squaring it. So that will simplify things some, but I'm going to go ahead and rationalize it first. Okay, -√2 over, that's going to be 2, and then √2 times √2 gives me a second factor of 2. So I'm getting 2 times 2, or 4, on the bottom. So that's my tangent of theta. So on top, I'm getting 2 copies of -√2 over 4. I'm just going to write that as 2 over 1 since I'm multiplying it by a fraction, over 1 minus -√2 over 4 quantity squared. So we do have some simplifying to do. The tangent formulas often lead to more simplifying. Let's see. On top, I can cancel that 2, so we'll have -√2 over 2. On bottom, this is going to become 1 minus, now when I square this, it becomes positive, so √2 squared is just 2 over 4 squared is 16. Now, I'm going to go ahead and rewrite that a little bit more. -√2 over 2 over. I can see this fraction is going to reduce to 1/8. So I'm just going to write that 1 as 8/8 minus 1/8. And then I can say that's -√2 over 2 divided by 7/8. This was a pretty easy subtraction problem to do, and that way I can deal with this complex fraction by just saying it's a fraction divided by a fraction. Let's flip and multiply. So -√2 over 2 times 8 over 7. 2 is going to go into 8 4 times, and so we'll have -4√2 over 7. Excellent.